Right, here's a bit of an application of vectors. A student rides their bicycle 8 kilometers southeast and then 15 kilometers northeast. Sketch a diagram using vectors and calculate the magnitude and true bearing of the net displacement. Okay, so our resultant vector. Okay, so let's start by putting in our compass points. So we know we have north, south, east, and west in those directions. And 8 kilometers southeast means we're exactly at a 45-degree angle from here. So let's go about that far down, and we're going to go exactly to there. And we're going to make that one, that's the direction they're traveling, and that's going to be 8 kilometers. And we can maybe call that U. Now I know that that angle there is 45 degrees. Southeast, it's exactly 45 degrees. All right, now he changes direction. So we're going to put in another compass point over here, which is again a north, south, east, and west. And this time he's driving 15 kilometers northeast. So exactly 45 degrees again, a bit longer than the 8 kilometers. So there we go. And this one we can maybe call V and make that 15 kilometers. And our resultant displacement, or our net displacement, our resultant vector is how to, oh, hang on, that didn't go very straight. Sometimes this thing doesn't let me do straight things like that. Let's rather use the ruler. Okay, our resultant vector goes from our start to our end. Notice head to tail our vectors. Okay, and let's call that one W. That will be our resultant. So we're going to say then, let W be the resultant vector. And I know that W is going to be U plus V. Now let's have a look at some of the things we know, all right? If this is a 45-degree angle, this is also a 45-degree angle, and we know that that's a 45-degree angle. And suddenly this becomes a really cool triangle because it is a right-angled triangle. And as soon as we've got a right-angled triangle, we can use normal trig and we can use Pythagoras. Okay. Now, in order to find the true bearing of our resultant vector, that bearing is going to be that angle there. That means I need to be able to find this whole angle over here so that I can subtract it from what I know the total angle is to find that angle alpha. Okay, so let's start. I'm going to communicate that I know this is a right angle triangle. And so therefore I can find my magnitude of W using Pythagoras. And that means I've got C squared is A squared plus B squared. Notice that my W is my hypotenuse. So that means I've got my magnitude of my vector W is my magnitude of U plus my magnitude of V squared. And that means that my magnitude of W will be plus or minus the square root of 8 squared plus 15 squared, and we discard the negative as distances are positive. So therefore the magnitude of W is going to be 17 kilometers. So that distance W is 17 kilometers. I still don't know what the angle is, but I can use another of algebra. So we're going to have tan of theta. Tan of my angle theta is opposite over adjacent. That will be 15 over 8. And theta will be my inverse tan of 15 over 8, which will be 61.93 degrees. All right, so my true bearing, in other words, would be my angle theta plus alpha. Okay, and I don't know what alpha is, but I know that theta minus 45 would give me that tiny little angle in there, and I know that alpha will be 90 minus that tiny little angle. Okay, so I can say my true bearing is going to be 90 degrees minus my whole angle theta minus the 45 degrees that I know about. So that's going to be 90 degrees minus 61.93 degrees, 39393 minus 45, and that means I have 73.07 degrees true. Okay, so therefore the net displacement is 17 kilometers on a bearing of approximately 73 degrees true. 073 true. Remember, when we have a true bearing, we're going to have 3